Question C wants us to hence prove that AC over 2 squared minus AB over 2 squared is equals to DF times FA. If you look at the memo, you'll see that there's an alternative way. There's two ways in which they do this. Both ways are similar to each other. It's just the first part of proving FC is different. So I'll show you how they prove FC on both parts, and then we'll go ahead and do the last part. So for the first method, let's write here, method 1. They start off with your left-hand side and say they understand that the left-hand side reads as AC over 2 squared minus AB over 2 squared. And if we square it out, we will have AC squared over 4 minus AB squared over 4. And if we look at it, they are talking about this triangle over here. We can see we can use Pythagoras theorem, where Pythagoras theorem says AC squared should be equals to BC squared plus AB squared. And therefore, we should understand that BC squared would be AC squared minus AB squared. And we can substitute that here and have this as BC squared over 4. Okay, with that being said, from question 2, we had proved in question 2 that the ratio between FC and BC was a 2:1, right? So therefore, if we want to then substitute BC for FC, we would then say that, sorry, let's not use that pen. We would then say that FC should be twice as much as BC. We'll have 4 CF squared over 4, and we will have this whole thing is equals to CF squared. So that's what we're proving, that the right-hand side is equals to CF squared. That's the important part. And that is when you use method 1. Now, when you use the method 2, we're proving the same thing here. We're going to look at the small triangle, this one over here. We'll start off with Pythagoras theorem that says OC squared is equals to CF squared plus OF squared, right? And we know the ratios between the small triangle to the big triangle. We know that FC over, what's that, the big one, BC over FC is the same as OC. We'll start with the big one, sorry, AC over OC, and it is A2:1. So what we're going to do is then we'll substitute the ones we have for the CFs. So first let's write it with regards to CF. We'll have CF squared is equals to OC squared minus OF squared, right? And then the OC can be substituted by the AC, but because it's twice as much, we will have to divide it by 2. So we will have here that AC over 2 squared minus AB over 2 squared is equals to CF squared. So in this case, what is important is to show that AC over 2 squared minus AB over 2 squared is equals to CF squared. You can show it using the big triangle, or you can show it using the small triangle. Either way, the relationship between the two will come into play. Once you have proven that, you're going to go to the next part. So the most important part here, we need to prove that the CF squared now is equivalent to DF multiplied by FA. So we'll go ahead and look at these two triangles here. We'll look at AFC and we'll look at EFD. Then from here, we can say that angle C1 and D are equal to each other because of angles in the same segment, and so is A1 and E. E1 and E are same. Sorry, it should be angles in the same segment. Let's rewrite that. Angles in the same segment, right? And obviously these ones are vertically opposite to each other, or we can look at the fact that they have, it's the third angle. So if the first two are equal to each other, it is then going to be that F on that triangle, so should be equal to F on that triangle, and therefore we can say that the angle of CFA is similar to the angle of DFE. So they are equiangulars. Okay, so it means that in terms of ratios, the CF over DF is equals to FA over FE, right? Ratio wise. But let's look at this. EC is a quad that has a line from the center and is perpendicular going through it, meaning that this must be equal to this according to the theorem. So we'll say that CF is equals to FE, and the reason is that line from the center perpendicular to the chord. Okay, once that is true, we can then change this to say CF over DF is equivalent to FA over CF. And if we multiply out, we'll have CF squared is equals to DF multiplied by CF. So that means we can go back and replace it in that equation. So we'll then say, therefore, AC over 2 squared minus AB over 2 squared is equals to DF. I made a mistake, supposed to be FA. It's supposed to be this value there. So multiplied by FA, because it is equals to CF squared, and we've seen that that is equals to also CF squared.